Hello and welcome to the third video in our series. This one's going to be a bit short. It's just a few little concepts that I need to bring up before we move on to our next longer video. The first thing is I just wanted to introduce you guys to some real circuits. Uh, this is an actual working circuit. This is a simulation of a simple heater circuit. So a heater in applied terms is really just a resistor. So right here, this is a symbol for resistor, this little squiggly line. And so is this one right here. These are two resistors in this circuit. Okay. Over here, we have the symbol for a cell. Okay, so a cell is just like a single portioning of a battery. A battery would actually be a different symbol. The symbol for a battery looks like this. So it looks like two cells on top of each other. I'm going to refer to that other thing as a battery just so I don't trip over my words, but this would be the symbol for a battery. And this is a cell, okay? But it's going to act as our DC source of voltage. So this circuit is using DC voltage. So the first thing you may notice is that I don't just have a simple wire running up here and over and down to this resistor and then down to this resistor. It's a closed loop that is necessary for current to flow in any circuit. So current will only flow in a circuit if there is a completed loop from the positive terminal back to the negative terminal. You can't just have a wire go over here and a wire go over here and that's it, and it'll energize things and make things happen. There has to be current flow, and there can only be current flow if the path from the positive terminal makes it all the way back to the negative terminal. Now, something that you may have noticed is that current in this is depicted as going up, over, down, and back to the negative. It's coming out of the positive. That may seem counterintuitive, as in the 2 videos ago I said that electrons have a negative charge, uh, so you'd think it'd be coming out the negative side and going to the positive one. You would be correct in that assumption. That is the way electrons flow. But Ben Franklin, when he was doing his experiments, guessed wrong at what direction that the charged particles flowed. Uh, and so now we have this. This is just the way that we all describe the way that current flows these days because we've carried it on. It's called conventional current flow, and it's kind of just something that we live with. It won't screw up any of your calculations if you use conventional current flow. Um, Anytime anybody is showing a circuit where current is depicted, this is the way they're going to show it. This is the way that I learned it, and it's the way we're going to be teaching it for the rest of this course. So again, just to reiterate, if I break this circuit with this is a switch right here. If I open it, you'll notice that there's still voltage everywhere, but no current is flowing. It's not unless you have a closed loop will there actually be current flow. So the other thing you may have noticed is these colors. It's green on this side until it gets back to here, in which it transitions to gray. That is depicting what is called voltage drop. So if you imagine that voltage is a lot like water pressure, voltage drop is a lot like pressure that develops across valves. If you imagine a pipe going into a smaller valve, there's a pressure differential across the valve. That similar phenomenon displays itself in uh, electrical circuits with a phenomenon called voltage drop. Even though all these are connected here, this circuit's all connected, if you put a voltmeter across this resistor, you would measure a voltage. Anywhere in an electrical circuit where there is resistance, there is a voltage drop. Okay, so there's going to be a voltage drop across this resistor and across this resistor. So we're going to go more into voltage drop in a couple more videos, but I just wanted to introduce it here and explain to you why these colors are here. So to reiterate everything we talked about, this is the symbol for a DC source we're going to be using. Okay, this is the direction of conventional current flow through the circuit. The circuit must be a closed loop in order for the current to flow. If we break the circuit and there is no closed loop, no current will flow. And whenever you have current moving through a circuit, when it moves through a portion where there is resistance, there will be a voltage drop across that resistance. Okay, and that's a lot like the water pressure that develops across a skinnier part of a pipe or through a partially closed valve. It is uh, a voltage differential caused by its resistance to the flow of current. All right, I'll catch you in the next video.